Okay, good morning, and we are now working on what is this? Discussion post 5, and we're working on writing hypotheses and null hypotheses. So I'm going to start sharing my window right away so I can talk you through how I'm going to do it. And here we go. So on my screen right now, you should see the same things that I had posted for 3 and 4, assignments 3 and 4. So we're following up with the next step, and in this case, it is we're going to take these questions and turn them into hypotheses. So if I take this first question in red, which was, let's say, the chi-square question, and I just take it down here and say hypothesis. Should probably do this in another color. Let's go with dark blue. Nah, let's go with green. We can make some pretty little words here. Okay, so a hypothesis is where I take this exact thing and instead of a question, I'm going to turn it into a statement. Instead of do differences exist, I'm going to turn it into differences exist. There. Differences in retention exist between teachers of different SES groups. Now it's a statement instead of a question, and that is a hypothesis. There is a null hypothesis. And the null hypothesis basically says that the hypothesis is wrong. So instead of making the statement again, we're going to say differences in retention do not exist. Whoa. Well, how are we going to know? When we run the test, how will we know which of these two statements is true? Well, there's something called a p-value. We usually set p at 0.05. And when you run the statistics, if your p-value is less than 0.05, then your hypothesis is considered correct because P represents the possibility that it could be completely by chance that your numbers look like there's a difference. And this is, there's a 90, if it's less than 0.05, then we're saying there's at least a 95% chance that this is real. It's not just by random luck that the numbers work this way. We're really very, very confident that this hypothesis is true. And we'll be able to say, yes, differences do exist. But if that p-value, I should have made that a little p. Okay, but if that p-value is greater than or equal to I don't have that symbol right offhand, so I'm just going to say greater. If p is greater than 0.05, then we have to accept the null hypothesis. If the p-value comes out 0.06, if it comes out 0.8, 0.5, anything that's bigger than 0.05, then we'll have to accept the null hypothesis, which basically says we were wrong. We thought differences existed in retention between teachers of different SES groups, but we were mistaken. It's probably random, and we can't make any important claims from our study. All right, so what did we do? We took the question, we made it a statement for the hypothesis. And if the p-value in the results are less than 0.05, that's the one that's right, and we get to call that the result. And if the p-value is bigger than 0.05, then we don't get to. If it's exactly 0.05, it's questionable. We'll just talk about it, but it's I've never seen it be exactly 0.05, so I'm not worried about that. Okay, so here's the next thing that we'll do the same thing with. That's the t-test question. And it is, do high SES teachers have different mean levels of teacher effect than middle SES teachers? Well, let's call it hypothesis. We'll make it a statement. We'll say high SES teachers do have, I just moved the word do, and it becomes a statement. Okay, so that's a hypothesis, so let's turn that green. And I just like to use different colors so that you can see that it's a different effort. The null hypothesis is basically the statement that we were wrong. So, did I spell hypothesis wrong? I don't think so. Oh, I'll put an extra space in there. Okay. We're going to turn that green again. And then we're going to make the null hypothesis. And the null hypothesis is simply the same thing, only saying that it's wrong. So high SES teachers do not have a different mean level. And all this is about being statistically significant. Okay, so the hypothesis, as always, we're going to have a p-value that's less than 0.05 in our results. You're going to run the test, and you're going to see a p-value amongst all the things in the table, and you'll know whether it's below or above 0.05. If it's less than 0.05, then we're very confident that this is true from our data. Okay, less than 0.05 is good. If the p-value is greater than 0.05, that means we have to reject the hypothesis and accept the null hypothesis, which says, no, there's not a difference. There's not a different mean level of teacher effect comparing high SES and middle SES teachers. Okay, well, this pretty much continues on. And we could do that with any of these. The one that I don't want you to write a hypothesis for is multiple regression. But all the other ones, you can write a hypothesis and null hypothesis based on your questions that have been corrected by your classmates. Most of you got your questions right in the first place. Some of you got a little correction or you want to update them, that's fine. So this post, you're going to write a hypothesis and a null hypothesis for each of the research questions that you've written in assignments 3 and 4. So just keep going down the list. And that will prepare you for interpreting the results. You do have to state the hypothesis and null hypothesis in your chapter 3 as you write the dissertation, and then in chapter 4 you'll run the results. You'll find a p-value reported from your computer analysis, and then you will decide, is it less than 0.05 and more than 0.05? So this is a really important step in the process to think about, so that you'll know in your results chapter 4, whether you're going to say, I accept the hypothesis or I accept the null hypothesis, which basically says I was mistaken. So it's relatively easy. You turn it into a statement, and then you turn it into a statement that says the opposite. If this says exist, this says do not exist. If this says do have different mean levels, then this says do not have mean levels. That's what the null means. You're nullifying statement. Okay, so that's what you're working on. You're going to do all of the questions that you wrote for 3 and 4. So the chi-square, the t-test, the ANOVA, ANCOVA, MANOVA, MANCOVA, and correlation. Do all of those. And as always, check each other's work, correct when they need correcting, You may not have as many deep thoughts on this one. So the 3 comments is off on this one. Just correct people when they need correction, or make a suggestion if you want to. The post is what I'm looking for, so it's going to be worth 10 points, and there's no pressure to correct people, because hopefully this one's a little easier. All right, it's just a little longer, but it's also a little easier. Now, I want to let you know what's happening on the next assignment. And what's coming up, and I will post details about it, is the next thing that's going to happen is that you are going to talk to me, and we are going to look at your quantitative worksheet. I'll post a video about how to fill out a quantitative analysis worksheet, but then we're going to have a phone call later this week, which we will schedule, and then we will we'll turn that in next week. We'll turn in the worksheet on its exact due date of June 3rd, but we will have talked about it on the phone so you can feel more comfortable with it, and then give you a little more time to work. So it's really just a warm up for the next assignment. But pay attention when I post discussion post 6 about the about that phone call with me, because there are things I'm going to ask you to post about the phone call. All right, I will see you guys online.